Okay, a particle. Number 2, a particle starts at x equals 0 and moves along the x-axis with v of t equal to 2t plus 1 for time t greater than or equal to 0. Where's the particle at t equals 4? So again, we want to find x of 4. Calculate x of 4 by going my starting position, so the position at t equals 0 plus displacement. So I just want to get that formula kind of drilled into your head. Okay? So if I'm going to calculate x of 4, I need to know its starting position, which again is 0, kind of lame, plus whatever the displacement is. How do we calculate the displacement one more time? Area of the curve. So this one's a little interesting, a little more interesting, because it's not a rectangle. If you go to 2t plus 1, how do you graph 2t plus 1? It's a line. Where does it start?
At 1.
It starts at 1. Y-intercept of 1. Everybody with me there? What's the slope?
Up to right 1.
So slope's going to be up to right 1. How far over do I got to go?
You gotta go up 8, I think.
So I got to go 1, 2, 3, 4. So I'm going to go up to right 1 again. Up to right 1 again. You get the idea. It's just going to go up.
Morris, who think Ben put laxatives in the brownies for April Fools?
Yeah, whatever.
I think just like them.
Okay, there it is. Anyways, you get my line there, right?
Here, on the brown.
Okay, that's good enough. That was a terrible line this time. All right, so there it is. There's the line. It goes on forever. But we only want from 0 to 4, so watch carefully here. From 0 to 4, that would be from here. Watch, guys, quiet. From 0 to 4 would be from here to here. What geometric shape do you have now? You have a trapezoid. This is good practice. So if I want to find the area of a trapezoid, you need to memorize this formula. It is required for the AP exam. If you don't know the area of a trapezoid, here it is. It is area is equal to 1/2 the height of the trapezoid times the sum of the bases. Now, how do you know what, people are always confused by this. How do you know what the bases are?
That's the ones that are parallel.
That's so simple. If you'll just keep up with one thing, the bases are always the parallel ones. So in this problem, the blue ones are the bases. Where's the height? Where's the height?
It's the x-axis.
The height is the one, listen, this is very important, because there's two other sides. The bases are the parallel ones. One of these is the height and one is not. The height is the one that is perpendicular, has to be perpendicular to the bases. Okay? Pretty simple. All right? I think they teach you area of a trapezoid in 7th grade. Okay? And then you learn it, you go over it, overhaul in geometry. All right? So if the black one is the height, what is the height then? What's the height of this trapezoid? 4. If the blue ones are the bases, we'll call this base 1. What is base 1? 1. What's base 2?
9.
Some people are like, I don't know. I have no clue what base 2 is. You know how you figured it out? Base 1 was at x equals 0. Plug 0 into the function. 0. 2 times 0 is 0. 0 plus 1 is 1. And if you can't count it out, then say, we'll plug 4 into the function. What's 2 times 4? 8 plus 1. So base 2 is 9. Now, this one was easy enough to count out, probably. Most of you didn't have to plug it into the function. But if you need to, you just plug it into the equation to get the heights, or the bases, or whatever it is you're looking for. So then area is going to be 1/2 times the height, which is 4, times the sum of the bases, which is 1 plus 9. What's 1 plus 9? 10. What's 1/2 of 4? 2. What's 2 plus 2 times 10? What's the area?
20.
Guess what? Same thing as last time. So then we're going to get x of 4 then is 0 plus what? 20. So x of 4 was 20 again. Now this is a different problem.
Did you have a...
It's not, it was just coincidence that they both ended up being
You
20.
just split it up into a rectangle and a triangle?
You could have, but I'm going to tell you, you need to memorize the trapezoid because there is a rule that's required on the AP exam. And you are required to use trapezoids when it says to use trapezoids. Okay? Now last year they did trapezoids, so chances are they're not going to do them again, but it does show up on the multiple choice too. Alright, now we get into ones where you're not going to be able to use a geometry formula to know. You're going to have to estimate. And when we estimate, we have to estimate according to the way they want you to partition it. So I'm going to teach you right now how to partition. Are you ready? Let's read the problem first. It says a particle starts at x equals 0. How boring. Do you want it to start somewhere else?
No.
Can we show what it is when it starts somewhere else?
Yeah.
Started at 5, 3, 4, 5.
Let's start it at x equals 5.
6.
And this next one will start at x equals
13.
3. But start still means what?
0.
Still means t equals 0. Time is still 0 when you're starting. So x of 0 here in number 3 is going to be 5. You still with me there? That makes sense. All right, and moves along the x-axis, so it's particle motion again, so it's moving left and right. Moves along the x-axis with a velocity of v of t equals t squared plus 1 for t greater than or equals 0. Where's the particle at t equals 4? So we're going to do the same thing. We're going to go x of 4 is starting position, x of 0 plus displacement. So according to that, x of 4 is going, what is our starting position? 5. So it's going to be 5 plus something, whatever that displacement is. All right, let's draw. Here we go. We're doing this by drawing tonight. It's all by hand tonight. So here we go. I'm going to draw a picture over here so I can make it very clear to you guys. All right. What do they want? It's going to be easy. It'll always be easy when they have you do this drawing. Okay? T squared plus 1. What am I drawing? Now, I'd make it really zoomed in. So I wouldn't make my parabola real small. So I'd make my 1 up really high, okay? So there's 1. And t squared plus 1 is going to look something like this.
Oh, it's down.
Why is it down?
Thank you. Why is it down? What am I smoking? Do it again. Sorry. Sorry, Emma. All right, so t squared plus 1. So I'm going to be up 1, and I'm drawing a parabola. There you go. Shift it up 1. So I want to calculate this from 0 to 4 again. I need the displacement from 0 to 4 because I want to know where it's at 4, and I know where it's at 0. So you go from where you know to where you want to go to figure out what you want to know.
Say that one more time.
I don't even know what I said. All right, so from 0, you need to go from where you know to where you want to go to get what you want to know. There, I did it.
I'm gonna listen
Okay,
to that one
you
on the
need help?
recording.
Are you running into some problems?
No, I
You want
don't.
to learn some math?
No, we're down there making movies, doing all sorts of great stuff, and I'm saying, somewhere in this school, there's some poor saps doing math somewhere.
Oh, cool.
We're having tons of fun.
So why are you
No.
there then?
No,
I'm videoing this, so
do you,
you're on my video.
either legally or illegally, are there things you write off for coaching on your taxes?
I do write off stuff. I do legally. I go to Peggy Cupkey, and she legally helps me write stuff off.
Like what? I mean, I know as teachers, you get $250 for supplies.
Education credit. I write off.
That's easy. That's the easy part. That's
That's
something
easy,
separate.
yeah.
So for coaching stuff.
Like any, she lets me write off any. Like if I buy running shoes and I train with the kids, she lets me write that off.
Miles for like driving too.
Any gear that I buy personally, if it came out of my pocket, team buys gear and I buy it, I can write it off. And you can do it. It's legal.
Golf.
What about like miles when you drive?
It's legal. Miles when you drive. Yeah.
New golf clubs.
Yes. If you play with them and you coach with them, it is legal.
Oh, what?
And I just got that on
Golf
video.
gloves?
Huh?
Golf gloves?
Yeah.
Golf shoes?
Yeah. Peggy
Golf
Cupkey would
balls.
say it's all legal.
Golf tees?
And I don't know how she does it, but
Golf hats? Because sunscreen I gotta get?
yes.
Shirts?
Sorry for the video here.
Shirts?
Yes. You notice that they always come to me for questions, though, and they always make fun of the math department. But he's always coming to me to ask questions. Oh, where the wisdom lies. Where the wisdom lies. All right. So I want to go from 0 to 4 and calculate that displacement. So I want to calculate this area. Look at this. Ready? I'm going to draw this neatly. Okay? I want to calculate this area under the curve from 0 to 4. But this is not a geometric area you know. I don't have an area of that. It kind of looks like a trapezoid, but it's curved. Dealio. Okay? So we got to pay attention. It says approximate the area under the curve using how many rectangles? 4 rectangles of equal width. That's important because here's the dealio. They don't always have to be equal width. In fact, the definition of a Riemann sum says they don't have to be equal width because if the number of rectangles approach infinity, even if they're equal width or not, they're eventually, those widths are going to approach 0 and you're going to end up with the area under the curve anyways. And I'll talk about that more tomorrow. So equal width though, whenever they have you draw, listen, quiet back there. If they ever have you draw, the width will be equal. If they don't have you draw and they give you a table without a drawing or an equation, the widths won't be equal. You'll have to partition yourself. They'll just say 4 rectangles. You'll just look at it and say, oh, there's 1, there's 2, there's 3, there's 4. I'll show you how to do that from a table in a moment. So I'm going to do the area under the curve, okay? Because the next one we're going to do is in the orange book. So here it is. There's our area, okay? So I want to find this area right here, this black area. I want to estimate it. I don't know how to find it exactly yet. It is actually easier to do exact. It's actually easier to do it exact than it is what we're about to do.
So why are we learning?
Because you have to do it on the exam. They require it. They don't even give you an equation. They're going to give you a table or a graph, and that's it. Here we go. We're going to do 4 equal rectangles. Here's the key. You need this formula to partition. Here's how you always partition. To get the widths of your rectangle, we're going to call the widths of the rectangle, we're going to call it delta x. Width of rectangles. You need to write this down. This should probably go in your notes. There's a little formula you need to memorize. And it's so simple. In fact, most of you will come up with it on your own. To way to partition something, it's so simple. You ready? You maybe have been taught this already in physics class if you were taught how to do metrics. Okay? Delta x, the width of your rectangle. All you have to do is take the entire length of the interval you want to divide up. So the interval is from A to B. Okay? So the width of the rectangle on A to B. Let's do that. So you know what A and B stand for. So on A to B. What's our A to B this time? 0 to 4. So the width of the rectangle, it's simply this. You take the left endpoint minus the right endpoint, and you divide by the number of rectangles. So simple. B minus A over N. N is the number of rectangles. I'll write that down. N, number of rectangles. That's simple. B minus A over N. So, what's the width of my interval? B minus A just represents the width of the interval. So that's going to be 4 minus 0 over, how many rectangles do we want?
4.
So what's 4 divided by 4?
1.
What's the width of the rectangles?
1.
Now, sometimes it's going to be easy. You won't even need to use the formula. But I'm going to tell you, sometimes it's not. Because what if I would have divided this into this? Some of you would have had a hard time coming up with it. Okay? You would have had a hard time coming up with the fact that you would have had to divide the interval up into 4/5 to get to your full interval. We'll look at that more as we go. So the first rectangle, you ready? Now, what did it say? LRAM, MRAM, or RRAM? MRAM. Oh, it just got complicated now. You thought it was easy because it was 1. But it just got complicated because I said I have to do it MRAM. So here we go. The first rectangle, if I'm going to go from 0 to 4, well, look at it. It's already divided up. 1, 2, 3, 4. Each rectangle of equal width, 1. And here's the dealio. To measure the height of your rectangle, you got to go to the midpoint. So between 0 and 1, what's the midpoint? 1/2. So you're going to go to 1/2. Watch this. Ready? Draw a little dot at 1/2.
Would you find the midpoint of the whole period?
Nope. You're doing each rectangle, the midpoint of each rectangle. We're not doing one rectangle. We're doing how many rectangles?
4.
So you'll
4.
actually do 8 rectangles then, or what?
Oh, no. Watch. One rectangle. Here's the first one. Ready? Everybody got the midpoint is 1/2? Draw. You're going to determine the height of that rectangle from the midpoint. Are you ready? I need everybody to look. I don't want you to draw. I just want you to look. I'm determining the height of the first rectangle from the midpoint. Watch. Here it goes. There's the height. Now you draw to the left endpoint and the right endpoint. There's your first rectangle from 0 to 1. Measured from the midpoint. Got it? See if you can draw the next one. Where would the next one be? What's the next one going to be?
1.5?
Let's do it as a fraction.
So
3 halves.
3 halves?
1.5, same thing, but we'll just keep it as a fraction and be consistent here. All right, what do you do with 3/2? Draw a dashed little line up. It is, but I want you to see it.
No, I'm here.
Yeah, it's hard to draw
It's
on
so
paper.
hard to do that.
I would do it on paper. All right, watch this. Ready to watch me? I'm at the height. Does everybody see it? Now go over to the left until you get to the left endpoint, and go over to the right. Now look at that second rectangle. It's kind of over on one part and under on the other part. Okay? Go to the next one. What's the next one going to be at? The reason I make you do this is you have to be visual about this to be able to see how you're going to write out the finite sum. It's a little weird. All right, over and under, or sorry, over and over to the left, over to the right until you get your rectangle. Go over to your endpoints. So the first rectangle was from 0 to 1. The next rectangle was from 1 to 2. The next one's from 2 to 3. Where's the last one? What's the last one? 3 to 4, so that's going to be 3.5 or 7/2. You can certainly use the decimals. I'm not going to make you use a fraction. Go up 7/2. And then draw it. And then what you would do, let me finish this, is you would calculate. Now watch this. What is the width of each one of these rectangles? 1. How you would do this is you would calculate the height based on the 1/2, the 3/2, the 5/2, and the 7/2. And how are you going to do that?
Plug it in the function.
You plug it into the function to find each one of those halves, or heights. Then you take 1 times that height, 1 times that height, 1 times that height, 1 times that height. You add up those areas of those 4 rectangles. That's your displacement, and you'll add it to this.
Is this the rest of this worksheet? Is that the homework today?
Yeah, I want you to try finish 3 and 4. That's it tonight. Wait, on Moodle, there's a 1 through 29 all, more practice on antiderivatives you have to do. So there's 29 problems, plus finish 3 and 4 here if you can.